z square into, this will become 2z plus 3 by 2, okay, by z minus 1 by 4 into z minus 1 into z minus 1 by 2, okay. So this is y of z, right? So now before continuing forward, I just need to give you an explanation of what is the natural response and what is forced response, right? So this is the output. This is called as the total response. So every solution of a difference equation or differential equations, there are two parts of the total output, or two parts of the response, and one is called as the natural response. Okay, this is called as the natural response, or also called as the free response, okay, natural response or free response. And the other one is called as the forced response. Okay. So natural response or free response is the response due to the initial conditions alone. Okay. So that means the output of the system due to the initial conditions alone is called as the natural response or free response. And when I say alone, I meant that the value of the input must be considered 0, right? So suppose if they're asking you to find the natural response alone, or find the natural response or free response, only find the natural response or free response, then how to find is then simply apply the initial conditions and then put x of n is equal to 0. This is how we find the value of the natural response or free response, okay. Here you need not do all that, because already you have found these conditions by excluding the input, right? Excluding the input, that means this is the term due to the input alone, right? And this is called as the forced response. That is, forced response means due to the input. And here the input specifically given is 1 by 4 raised to n u of n. So this is how we define the forced response, right? We define forced response by saying that output due to the input of, and we say that the input value is 1 by 4 raised to n u of n. Okay, so this is what we call as the forced response. So forced response means output of the system due to the input alone, and natural response or free response is the output of the system due to the initial conditions alone. Okay, so here usually when we are finding only the natural response, we put the input equal to 0, and here when we are finding only the forced response, we put the initial conditions equal to 0, and that's how we apply both the terms. Okay, so from these two you can understand that the transfer function that you have found out later, that is used over here, right? Here the transfer functions are not applied over here because this is due to the initial conditions, right? So natural response plus forced response is equal to the total output y of z, total response. So y of z is also called as the total response. Okay, so basically what I meant is that we are going to find y of z is equal to y1 of z plus y2 of z. y1 of z is the natural response, y2 of z is the forced response. So what I'm going to do is I'm going to find y1 of z separately, then I'm going to find y2 of z separately, and then I will add these two together to find my y of z. Okay, so first let me find y1 of z. So y1 of z is equal to minus 1 by 2 z square by z minus 1 into z minus 1 by 2. Okay, so now to apply partial fraction, I need to preserve one z at the denominator, right? So this will become y1 of z by z is equal to minus 1 by 2 z by z minus 1 into z minus 1 by 2. Okay, this I'm going to now factorize this into two terms. That will be a by z minus 1 plus b by z minus 1 by 2. Now I'm going to find the value of a, and the value of a is, remove the term z minus 1 from here and substitute z is equal to 1. You get minus 1 by 2 z by z minus 1 by 2, where z is equal to 1, and you will get minus 1 by 2 by, and this will become 1 minus 1 by 2. 1 minus 1 by 2 is 1 by 2. So the value of a is equal to minus 1. Okay, value of a is equal to minus 1, and the value of b, to find the value of b, z minus 1 by 2. So remove z minus 1 by 2 from here, write the remaining terms by z minus 1, and then substitute the value of z is equal to 1 by 2. So z is equal to 1 by 2. So you will get over here as minus 1 by 2 into 1 by 2 is minus 1 by 4 by, and 1 by 2 minus 1 is minus 1 by 2. Minus and minus will get cancelled, and 2 will, here this will become 2 will become 1, 4 will become 2, so this will become 1 by 2. So the value of b is 1 by 2. Okay, so you found the value of a, now you found the value of b. So now I can find the value of y1 of z. So therefore y1 of z by z is y1 of z by z is minus 1 by, let me see, minus 1 by z minus 1 plus, and b is 1 by 2. So 1 by 2 by z minus 1 by 2. In other words, your y1 of z is equal to minus 1 into z by z minus 1 plus 1 by 2 into z by z minus 1 by 2. Okay, and therefore y1 of n, this is called as the natural response or free response, right? y1 of n is nothing but we don't need to, I think we don't need to find that, because we can, okay, anyway I'll write it anyway. So y1 of n is equal to minus 1 into 1 raised to n u of n plus, this is 1 by 2, and this is 1 by 2 raised to n u of n. Alright, 1 raised to n is 1 itself, right? So this is nothing but minus u of n plus 1 by 2 into 1 by 2 raised to n u of n. Okay, so like that I found the value of the natural response y1 of n. Okay, so now I'm going to find the y2 of n, that is the forced response. y2 of z is given by, let me see, what is y2 of z? y2 of z, right? y2 of z is z square into 2z plus 3 by 2. Let me write it over here. So it will become z square into 2z plus 3 by 2 by, right, and the first term is z minus 1 by 4. So z minus 1 by 4, the second one is z minus 1, and the other one is z minus 1 by 2. Okay, so now you are going to find the inverse of this. So what I do is I need to preserve one z at the denominator. So y2 of z by z is equal to, and the remaining is z into 2z plus 3 by 2 by z minus 1 by 4 into z minus 1 into z minus 1 by 2. Okay, so now I'm going to apply partial fraction over here. So this will become a by z minus 1 by 4 plus b by z minus 1 plus c by z minus 1 by 2. Okay, so now I'm going to find the value of a, b and c. So to find the value of a, Find the value of A. The denominator of A is Z minus 1 by 4. So remove Z minus 1 by 4 and write the remaining expression. Z into 2Z plus 3 by 2 by, and here it will become Z minus 1 into Z minus 1 by 2. Okay, and substitute the value of Z is equal to Z minus 1 by 4 equal to 0. So Z is equal to 1 by 4. So therefore the value of A is, here it will become 1 by 4 into, here it will become 1 by 2 plus 3 by 2, right? This is 1 by 2 plus 3 by 2. 1 by 2 plus 3 by 2 is 4 by 2, right? 4 by 2. Let me write 4 by 2 over here just for my easiness. 4 by 2 plus, and here it will become 1 by 4 minus 1. 1 by 4 minus 1 is minus 3 by 4, and 1 by 4 minus 1 by 2 is minus 1 by 4. Okay, so how do we do this problem? This one and this one will get cancelled, and this one and this one will become 2. So therefore the value of A is, let me see, it will become this 4 into 2 8. 8 will come in the numerator, so, and minus 3 into minus 1 is 3, so it will become 8 by 3. So the value of A is 8 by 3, right? So now I'm going to find the value of B. So to find the value of B, remove Z minus 1 from the denominator, from this factor, write the remaining expression. Z into 2Z plus 3 by 2 by Z minus 1 by 4 into Z minus 1 by 2. Okay, and then substitute the value of Z is equal to 1. So Z is equal to 1. Okay, so you will get over here as 1 into 2 plus 3 by 2 by, here this is 1 minus 1 by 4 is 3 by 4, and 1 minus 1 by 2 is 1 by 2, and here it is, this is nothing but 2 into 4, 2 into 2 is 4, 4 plus 3 is 7, so you will get 7 by 2 by 3 by 4 into 1 by 2. This 2 and this 2 will get cancelled. This 4 comes on the top, so this will become 28 by 3. Therefore the value of B is equal to 28 by 3. So I found the value of A and I found the value of B. Now I need to find the value of C. Okay, so to find the value of C, let me see. To find the value of C, here the denominator of C is Z minus 1 by 2. So remove Z minus 1 by 2 and write the remaining expression. You will get Z into 2Z plus 3 by 2 by, here it is Z minus 1 by 4 into Z minus 1. Okay, and then the value of Z should be, let me see, Z minus 1 by 2 equal to 0. Therefore Z is equal to 1 by 2. So substitute the value of Z is equal to 1 by 2. So in that case this will become, so this will become 1 by 2 into, this is 1 by 2 into 2 is 1 plus 3 by 2 by, and this is 1 by 2 minus 1 by 4 is 1 by 4, and 1 by 2 minus 1 is minus 1 by 2. Okay, or this can also be written as, 1 by 2 into, this is 2 plus 3 5, so 5 by 2 by, this is 1 by 4 into minus 1 by 2. Okay, so maybe I can cancel this 2 and this 2 with this 4, and one more thing is that this 2 will come on the top, so the answer will be minus 10, right? So the value of C is minus 10. So now I found the value of A, B and C. Substitute those values in the given equation. So therefore y of Z by Z, right? Y of Z by Z is, the value of A is 8 by 3. 8 by 3. So put over here 8 by 3. So this will become 8 by 3 into 1 by Z minus 1 by 4. Okay, and the value of b is 28 by 3. So substitute 28 by 3 over here. So it will become plus 28 by 3 into 1 by z minus 1, and then the value of c is minus 10. So minus 10 into 1 by z minus 1 by 2. Okay, so now I can put this preserved z back into the numerator. So this will become y of z. It's not y of z, it's y2 of z, right? Y2 of z, because this is the forced response, the second output. Y2 of z. Y2 of z is equal to 8 by 3 z by z minus 1 by 4 plus 28 by 3 into z by z minus 1 minus 10 into z by z minus 1 by 2. Okay, so this is the answer you got. So therefore from here I can say what is y2 of n, right? Y2 of n is nothing but I can now take the inverse of this. So this will become 8 by 3 into, and this is nothing but 1 by 4 raised to n u of n plus 28 by 3, and this is nothing but 1 raised to n u of n minus, and this is nothing but minus 10 into 1 by 2 raised to n u of n. So this is y2 of n. Okay, and since y of z is equal to y1 of z plus y2 of z, then according to linearity property, the total response y1 of n is equal to the natural response plus the forced response, right? This is the response due to initial conditions only, and this is the response due to the input only. And here this is called as the natural response, this is called as the forced response. Okay, and the natural response, the value for the natural response we have already discovered, it is minus u of n plus 1 by 2 raised to n u of n, right? So therefore minus u of n plus 1 by 2 into 1 by 2 raised to n u of n. Okay, plus now y2 of n is 8 by 3 1 by 4 raised to n u of n plus 1 raised to n is 1 itself, so I can write 28 by 3 u of n. Okay, u of n minus 10 into 1 by 2 raised to n u of n. Okay, so now this is the final answer. Maybe I can join these two into one value, right? So this will become, so maybe I can take u of n common over here. So this will become 28 by 3 minus 1, right, into u of n. That's what we can see over here. Plus, and maybe I can combine these two also, right, because these two are having the same value, right, except the last one. So I can combine these two also. So this will become 1 by 2 minus 10 into 1 by 2 raised to n u of n. Okay, and there is nothing for here, right? So this is written as plus 8 by 3 1 by 4 raised to n u of n, right? So therefore y of n is equal to, this is 28 minus 3 by 3, so that is 28 minus 3 is 25, so you will have 25 by 3 u of n, and this is 1 minus 20 is minus 19 by 2 into 1 by 2 raised to n u of n, and this is plus 8 by 3 into 1 by 4 raised to n u of n. Okay, this is the answer. Or we can finally say that y of n is equal to 25 by 3 minus 19 by 2 into 1 by 2 raised to n plus 8 by 3 into 1 by 4 raised to n into u of n. This is the final answer. Okay, so this is the total response by of n. This is how we do the problems. Okay.